Is Spring Boot. In this video you're going to look into a Spring Boot application, simple Spring Boot application. See how Spring Boot works, the inner workings of the Spring Boot application, and see we as hackers how we can exploit the Spring Boot application. So Spring Boot is an open source Java framework used to create microservices. It's used for programming of web applications, or REST APIs, and it's a framework built on Java, and it's good to bootstrap APIs or web applications. It uses an MVC architecture, that is the model view controller architecture design pattern, which organizes the application into distinct layers, each of which carries a specific function, which we'll look into. So there's a model, there's a view, and there's a controller. So whenever an end user make a request, the controller is the one that handles the request flow and never handles data logic, just handles the control. So from the controller we can move, the logic can move into the model where the logic is and where interaction to the database is done, to probably fetch, update the database, and the view is what handles data presentation, or what the user sees at the end. So Spring Boot is built on this architecture, and the response is given back to the end user. I'll give you an example of a request to an API that will fetch products from the database. The controller is what will handle that request. There will be some model or service layer where this data is fetched from the database, and this data is compiled or is added to our views. This could be HTML or any other front-end framework, which is presented to the end user. So for the basic, there's also some CRUD operations. What CRUD operations are is basically what builds up the web application. Actions that are done into a web application, that is to create. Maybe you are creating products, you are reading products, you are updating a product, or you are deleting a product. So in this video we are going to see how to hack into a Spring Boot application, a simple Spring Boot application that I have here, product manager, that just manages different products for different reasons into a database. So for this we are going to have such a layout, so such a design pattern, where we have the controller, the model, the view, and the database. For our database, we have an already existing MySQL database with one table called product. The database is sales. We are going to see how to connect our Spring Boot application into this database, which the database bring the dynamic aspect of the application to help us store many users products and update them in real time. Also, we'll have our Burp suite on so that we are able to see these requests that are made into our application. So I'll fire up our application as I explain how Spring Boot packaging is done. So our code is packaged in different packages. We have the controllers, as we did see. These are the ones that handle the request. So whenever a request is made to this application, the controller is the one that handles all the requests. You're going to see how this happens. You have the model that will model the real world product, and this is also what represents the database, or what sits at the database. The repository, it's a helper to interact with the database, to fetch, to update, to delete. The service is where most of the logic will reside. You have, so for a Spring Boot application, you have the main source folder, which holds most of the application code. You have a main folder under it. There is Java and resource. The Java folder will hold the Java code, since Spring Boot is built on Java, so we'll have Java classes on this Java folder, and have a resource folder where we have the templates, which represent the view, which will show us the view end of the application, or what is served to the end user. So under resource also we can have also images that are being used by the application, some JS files that are being used by the application, and we also have an important file here, application.property, which controls how our application runs, or how our application interacts with the other applications, like the database of the MySQL. So already I've created an MySQL database called sales, and this is how we connect that to our application. Is a spring.datasource.url yam that indicates that our application is connected to this sales database. Under that sales database, we have tables, and in this case we have just one table which don't have any product at the moment. If we select this, let's connect that, nothing is returned since we don't have any saved product at the moment. So we also have the database username and password. At the moment we're using root, not password, since it's for demo purpose. We also have a port. We are defining port 8082. That's where our application will be running at, port 8082. The reason I defined another port is since we already have a proxy running on port 8080, and port 8080 is the default Spring Boot port, so we needed to change that. Yeah, so different packagings where controllers models are put into different packages, and if you go to more advanced applications, there'll be more packagings on you, like utils, that are helpful. So packaging is all about keeping the application well organized for the ease of the developer. So I already fired up the application, and it's accessible at port 8082. So to hack this up, or to see how a Spring Boot app would work, all we need to do is visit the root URL of the application where the application is served. Since we said the application it's at port 8082, that's where the application is being served, and it's running. So whenever a user will visit our web application, at the root mapping, we get a response with an option to create a new product and a table with product ID, name, and some attributes here. This is product list. To see how this came to be, we'll start. This is the developer tools. Let me close this and open again. More tools, developer tools. This is helpful to see the request also from our browser. So when a user visits or make a request to our application, that is our end user making a request to our application, we see the controller is the one that handles the request. So the browser made a get request. The request method is a get request to our root mapping, and we are served with this. So to see this, so from the Burp suite captured that request. So since the controller is the one that handles requests from the external world into our application, so we have the default mapping, the root mapping. It is at request mapping, and some developers will use some guest will define the method that is required. So this is generic, it will accept any method. So in this case, the browser made a get request to the root mapping. So that request was handled by the controller, and it was mapped to this method, since this is the root mapping. So the method is view home page, and all that this method does is it creates a list of products, and then calls a service. There's a product service. Now at this point, the controller calls a service into the model that interacts with the database to list all the products that are in the database. And since there are no products at the moment, this returned 0 product as of now. Then this was returned to the controller. This return back. Okay, there's this return back with data from the database into the controller, and now we need to represent or to show this to the end user. That's where the view comes in, and we have a model attribute. We have a model. We added the model UI model so that we can view this from the different views that we have, and we added the model some attributes of the list of products that we fetched. At the moment it's 0, the list product. Then our function returns the index view. So if we open the index view, we see the list of products that we defined in the that we did add in the list of products that we did add in the model with the UI, and the different attributes of the product. And this is a table. That's why we are able to see this table with different attributes but no product at the moment, since our database is empty and nothing was fetched at this line from the database. That's why we are able to view this page. And also this page holds an option to create new product. There's a link, href, to create new products that it's mapped to new. So from here we have an option to create a new product. Once we click on new product, the browser makes another get request to /new now a mapping of /new, and you can see this from the browser. So this is an endpoint to /new. Again, the controller is the one that handles the request. So the request will come into this controller, and we have a request mapping of /new. No method is specified, so this is mapped to this function. What now happens is we are inputting our model for the UI as usual. Then we are instantiating a new model called product. New model called product. The model is, like I said, it's what represents the database, or the logic now to save this into the database. So we're initiating a new product, and we're adding a model product with the model product. Then we are returning a view of new product. So what this happen is, this is a form, as we can see. To create a new product name is required, the brand, median, and the price. All these are the attributes that are required. That's why we had to instantiate. We call this instantiation of a new product, so that we can map the required attributes of this product, the ID, the name, the brand, the median, and the price. We can map that with whatever the user or the end user will input and click save on. Since this is a form, there's an action that is mapped to /save. So let's create a product, maybe a TV or a car. Let's create a car. Brand is BM, made in Germany. Can have a price of 120. This could be any currency. So on clicking save, here's our request. The browser made a post request. The method at this time is post to /save. The browser made a request to /save in the method of post. Is also picked by the Burp suite. Here's our parameters, and here's where now we as hackers can send this to intruder, repeater, to just mess up with the application, see if there are some SQL injection, see if there are any restrictions on the price, and this can be broad. So a post request was made to a /save. Since every request is handled by the controller, and a controller there must be a /save. It is that is expecting our method of post. Unlike the other mappings, here we are specifying that we need a request of method post, and the name of this function is save product, and it expects a model attribute of product. Remember, from the new product view, we created a model product, and the user will have filled the required attributes or properties for this product. So from here we are getting the product that will be sent from the form, and all we are doing here is service.save. We are saving this product to the database. The service layer is where the logic to save that calls the repository that interacts with the database. That's the save. Then upon saving this to the database, let's follow this. This is the product service that has a repository, a product repository that saves this into the database. After saving, we return a redirect to the route mapping. Again, the route mapping has this function that will fetch products from the database. In this case, the product is 1, since we already have a product now in our database. If we select all from the product, we have 1 product in the database. So the controller will receive this data. So we made a request to save, and we are redirected to the route mapping, where now the application will make another request to the database, and whatever is returned as product, we create a list of product attributes, and then we return the index HTML now that has products that can be listed in our table. For each, there's some logic to list all the products in the database. Since it's just one product, we are able to view this product. We can create another product, and the same is done. There's a get request to /new. Our controller handles all the requests, so there must be a /new request mapping that will instantiate this product and return a view of new product that gives us this provision to create a product. This time let's create a TV, Sony, in say Germany or so, and a price of 120. Then we click save. On save, a post request is made to /save, and all this time our BAP suite is still capturing the request, that we can head on with our application security checks, and a new product is being added. Now we have 2 products. Since we said we are looking at the CRUD operations, we've managed to create a product. We've managed to read products from the database. Let's see on update and delete. So since we have our products, there's a provision also to edit a product. On clicking edit, a request is made to an endpoint /edit, and then the product ID, and the method is get. So from our controllers, there must be a /edit with an ID expected, and this is mapped to this method show edit product page. Our ID is extracted from the path variable. This is the path variable. Is our BAP suite request /6 is our variable, and we have a model view being created here, and we are using the edit product view so that we are able to edit this product. We are also fetching the product that we need to edit from the database using the ID extracted, and we are mapping this to this product to our model view, and then we return the model and view of the edit. So our product is auto-filled. Since this is from the database, it's auto-filled, and we are able to edit our product. We could edit this to a brand, and we could edit this to and increase the price maybe to 150 and edit. Then we click save, and the same is repeated. /save method is made to our endpoint where the controller takes effect. /save method of post, and then we are the product that we send from the front end, and there's a redirect to the root folder, to the root mapping, where we fetch the different products in the DB. Currently there are two, and one is already updated, and that's why we are able to say we just did update the brand. So that's how generally Spring Boot would work. From the end user, the controller handles the logic, the controller handles the request flow. The model, it's all about the logic and the database interaction. Then the view is how we represent this data. Finally, we have the delete option. On clicking delete, the application makes a /delete request to the endpoint /delete with the ID of 6. It's a get request. We go to our controller, there must be a /delete request mapping. So this is, we are mapping any request to this /delete, and there's an ID. All that this function, there's a function to delete product. We extract the ID from the request, and we are able to delete the ID. We are able to delete the product using the ID. Then we redirect to the root mapping, which fetches the product, which at the moment now it's 1, and we are able to display our 1 product. So from the Burp suite, we are able to see this request, and we are able to send them probably to the repeater. We can try to delete, instead of 6, we can try to delete 5 and see what happens. We are presented with an error since there's no proper error message for product entity since no product entity with ID 5. That's why we're able to see this error. It's no product with ID 5, product with ID 6, and this is how an attacker would not try to hack and delete other. We're able to delete a product with 7. They're able to delete either other users' product or product that they are not supposed to delete. So that's how, basically, in simple form, a Spring Boot application works, and how they are built, and how this is simple, though they are different ways to build on this. I'm sure developers would agree on that. But for application security engineers, this will be helpful to know how the request flows and how everything is put into place, and how to look into different ways to exploit this. So that's it for this video, and cheers.